Good morning everyone. Today we are going to discuss chapter 12, electricity. Electricity is an important chapter in the class 10, and in this chapter we are going to discuss about electric current, circuit diagram, electric potential and potential difference, Ohm's law and all. First of all, let us know what is electric current. So as per the definition, we already learned that electric current is the rate of flow of electric charge. What do you mean by electric charge then? So we have already learned in the lower classes that there are two types of charges, positive and negative charges. Okay, these two positive charges, they have their own properties and characteristics. So if we consider only this charge, how we can define a charge? So we may say that charge is a fundamental property. Okay, what is a charge? It's a fundamental property of then how we can connect this charge fundamental property, that we can relate this charge to the mass of a material. Okay, and we know that mass is another fundamental property of matter or material. Then what do you mean by mass? And simply by the definition we define the mass is that the amount of matter contained in a material or matter. So for example, if we have a material, a metal ball we have, okay, and this is made of iron. So how much amount of iron is used to make this ball? That gives the mass of that ball, iron ball. Okay, and likewise the charge is also a fundamental property. Okay, and easily we can relate this charge to the mass, which is also a fundamental property of matter or material. So electric current is a rate of flow of electric charges. How we can express this electric current? So electric current is expressed by the amount of charge flowing through a unit area per unit time is known as the electric current. Okay, the amount of charge flowing through per unit area per unit time can be expressed by the electric current, or simply we may say rate of flow of charge. How much amount of the rate of flow means how much amount of charge is flowing through a conductor or through a unit area per unit time. So as we already say, electric charges are of two types. Okay, positive charges are there, positive and negative charges. How does the positive and negative charges are formed? So we know that if we describe about a material and we learn much deep about a material, and finally we come to the entity of that matter, that is atom. Okay, atom is made of protons, neutrons and electrons. And so protons have this positive charge and electrons are negatively charged. Neutrons are chargeless particles. Okay, they are neutral particles. So these protons and neutrons are concentrated in the center of an atom, which is called as nucleus, and electrons are revolving around this nucleus. And the electrostatic force between the protons and electrons are made them to revolve around. They are held them together. Okay. So we know that when we compare these positive and negative charges to the magnetic property of a material, we know that if we talk about a magnet, so a magnet has north pole and south pole. Okay, so we all know about these magnets, and we also played with magnets, and we know that when a north and north pole they comes together, see, when two magnets brought nearby and a north pole and north pole comes together, what happens? They repel each other. And south pole and south pole comes together, then they repel each other. But when a north pole and south pole comes together, they attract each other. Likewise, there is an electrostatic force between these protons and electrons because they are opposite charges. Okay, protons are positively charged and electrons are negatively charged. When positively charged come together, they repel each other. When electrons come together or negatively charged come together, they repel each other. But a positive charge and negative charge, they comes together, they attract each other. Okay. Likewise, in the case of a magnet. So these are the characteristics of positively and negatively charged. And how does these charges are formed? So we have learned in the lower classes that how we can charge a, for example, if you take a plastic roll, assume that this is positively charged. Okay, then how a rod can be only positively charged? Is it possible? No, because in the beginning we have said that every matter is made of atom. That means the smallest entity of any material is the atom. Atoms are made of protons and neutrons and electrons. So positively and negatively charged particles are there in the atom. But how a plastic rod can be positively charged? What does it mean? Does it mean that only positively charged particles are there? No. But the number of positively charged particles are more in that case. I mean in the plastic rod. How it is possible? So the number of atoms are there, positively charged particles, negatively charged particles are also present in the plastic rod because the plastic rod is made of atoms of plastics. So there are electrons are there, that means negatively charged particles are there, positively charged particles are there, means protons are there. But in this particular case, number of protons are more here. That is why this rod is positively charged. Then the another one, these positively charged particles, positively charged rod is rubbed on against a silk cloth. What happens? This rod can attract some pieces of paper. That means that this rod is positively charged and this positively charged particle or rod can attract the negatively charged particles. That means the negatively charged particle. Then how does this an object or material can be negatively charged? Same as we explained in this case, the number of electrons are more in that particular object or material. So therefore it is negatively charged. It doesn't mean that that particular object does not possess protons. Protons are also there, but the number of electrons are more in that matter or the material. So it is negatively charged. This is how the positively and negatively charged particles are formed. Okay, or an object is either positively or negatively charged. How we can measure? So as we already said, electric current is the rate of flow of charge. Then how we can measure this electric current flowing through a body or a material or a conductor? So the electric current is normally denoted by the letter I. So I, electric current, or sometimes we simply say current. Then the total amount of charge flowing through a conductor or through a body is taken as Q. So that is what the total amount of charge. Then the net amount of charge Q is flowing through a conductor or through a body for a time T, and that is the time by which the charge Q, the net charge Q is flowing through a conductor. Then how we can measure this electric current? The electric current I can be written as I is equal to total charge flowing through the conductor or through the body divided by 10. I is equal to Q by T, where Q is the net charge flowing through the material and the T is the time by which the charge flows. The SI unit of electric current. So as we know that the SI unit of charge Q is Coulomb. And the SI unit of time is second. So we must get Coulomb per second is the, or you may write Coulomb per second is the SI unit of charge. And this is, and the unit is termed as ampere. So the SI unit of electric current is ampere. The name ampere is given after the name of a French scientist, André Marie Ampere. How we can define 1 ampere? So the amount of charge flowing through the conductor. The 1 coulomb of charge is contained 6 into 10 raised to 18 electrons. Okay. 1 coulomb of is equal to 6 into 10 raised to the power 18 electrons are there, and the charge of 1 electron, as we already know, 1 electron is equal to 1.6 into 10 raised to minus 19 coulomb. How we can define 1 ampere? So therefore we can define 1 ampere is equal to 1 coulomb divided by 1 second. That means the 1 ampere of current can be defined as when 1 coulomb of charge flowing through a conductor for 1 second. So 1 ampere is the SI unit, and this SI unit has higher units and lower units also. Sometimes when the current is to be measured a unit lower than this, then we use the smaller unit as 1 milliampere, and 1 milliampere is equal to 10 raised to minus 3 ampere, and also we use 1 microampere, that is equal to 10 raised to minus 6 ampere. An instrument that used to measure the current flowing through a body or a circuit is known as ammeter. Ammeter is used to measure the electric current flowing through a circuit. Then here we say that electric circuit. Then what do you mean by electric circuit? So as we know that in order to flow a charge, then there must be a path or there must be a conductor through which the charges can flow. Then an electric circuit, or simply we say a circuit, can be defined as a continuous closed path through which the electric charges can flow. What are the components of an electric circuit? An electric circuit consists of a conductor, and also it consists of switch or key, and again a bulb. Okay, a simple electric circuit can be represented by, okay, there should be a bulb, okay, and battery, and also a key, and this gives a simple circuit diagram. And a circuit diagram is a closed continuous path which consists of symbols of various components present in that circuit. So here this symbol represents the bulb, and this symbol represents the battery. So positive terminal and negative terminal, and this is the symbol of a switch or a key. So this is a representation of a simple circuit diagram. Then what do you mean by a circuit diagram? A circuit diagram is a representation of the circuit, electrical circuit, with the help of the symbols of various components present in that circuit. So that's all about electric current, electric circuit, and and circuit diagram.